my knee, you should need it. So like, so I think, you know, I think it's more than before. It's just about getting.
We are up and ready to go in.
Getting something.
It's like, is this what I?
It's like, I think going towards, you know, there.
Okay, we can get started. This is Weather Watch for January 31st. And before I begin, I would like to welcome back the esteemed Michael Morgan, who will be giving the forecast after a 4-year stint. 2.5 person. Too long, but welcome back.
Thank you.
I'll start out with the week-long IR loop, so I'll let this start again. It's been a relatively boring week here, aside from what happened yesterday, which I'll point out. But we can watch the evolution. So it's been cold out west. You can see as night happens, daytime comes, this is all temperatures as cold as the clouds moving overhead. In Canada, which I'll point this out once this happens again, they had one of the, right around the tip of Hudson Bay, this storm was the strongest to ever occur in that region of the world, according to sea level pressure records, and I'll point this out again. So we'll watch. There's going to be a dip in the jet stream that happens. You can see all these high clouds will start to move towards Hudson Bay right here. Right where you expect it, next region, here comes a cyclone forming. Got down to 965, which is the lowest pressure in that region of the world. And then it moves off, and it's been sitting off of Greenland. You can see that's the same storm. I'll keep my cursor there, and it's just been sitting there since then, and causing a lot of mayhem, I'm sure. You can see in its wake, once this happens again too. We'll watch this evolution. Very cold, so this is all Arctic air. All of these yellows and greens that don't move, like the clouds are moving, I'll point this out here. So here goes the storm. In its wake, here's really cold air on the backside. So imagine having, you know, I don't know, 6 to 12 inches of snow, and then all of a sudden you're getting minus 30 degrees, and it's windy, incredible. Not a lot of people live there, but still something interesting to note.
So, Patrick,
Yeah.
just curious,
Yeah.
for that part of the world, it seems like the 965 doesn't seem incredibly low. I mean, it's low, but
Yeah, I would agree. Go ahead, sorry.
So I was just curious, is that just sort of an anomalously region of higher record low minimum pressures in that part of the continent?
I think so. The previous low pressure record was 967.
Okay.
So didn't beat it by a mile. And I'm sure it might be due to lack of observations too, I would think. Because the nearest station is on the other side of this bay, Hudson Bay, and then this little dip in it.
Right.
So that's the nearest thing you compare it to, but yeah. What else? Oh, there's an interesting band of precipitation just to our south. You'll see at the end of this loop here, formed over Nebraska, Iowa, and then has slowly drifted with the formation of a cyclone over the eastern United States, and that's been producing precip. We won't get any, we haven't had precip in a while, but you can watch that evolution here again. So we'll see nice warm flow up from the Gulf. Here's the cyclone, and then here's the formation of the next weather maker. You'll see it move slowly to the east, and here's that band of precipitation. Not going to make it into our region, but we'll diagnose that because it's interesting. And then at the very end, this will be the last thing I point out from this loop. You'll see what's going to be the next potential weather maker, at least for the western portion of the United States at this moment here. So we'll watch this. You'll see at the very end, indicated by all the higher clouds, a lot of moisture is being suddenly brought into the western portion of the United States. You can see it right along here. It'll be like a fire hose that'll just bring moisture straight into places that need rain. I mean, California, we've heard about that. All the tragedies going on, but there will be a lot of moisture, and it seems like it's just gunning for Central California at this point. Unsure if this moisture will make its way into our region, but this is something to watch. This will be our next event here. And yeah, okay. And then can we go to our AOS climate page, please? So I want to point out what happened yesterday because there was something very interesting. And we'll see here in the temperatures. Look at this. That was our high temperature yesterday, 57 degrees. The previous record was 47 degrees. So we beat it by 10 degrees. And just yesterday was a beautiful January day. if you were to tell me 57 degrees in January was gonna happen, I think you're crazy, personally. And that high temperature, if we follow along, is like the normal temperature for April 15th. So that's how weird yesterday was. 57 degrees, and you can see how high it is compared to our average highs, which is this red line here. Just last week we were minus 13, and then we were 57 degrees.
So that's kind of weird that, even though it was relatively mild yesterday, I guess you could say it wasn't too taxing, right? April 15th.
Very true.
Are you sure that
Boy, did we miss that, didn't we?
are you sure that the record was 48? Ed had sent me and said that yesterday's 57 was the second highest daily high since 1869. It was a tie with 1874, and the highest was 58 in 1880. Or is that for January overall?
Maybe it's January, because this National Weather Service had the daily
Yeah, I
high
saw the
was
same
47.
thing.
So
Yeah,
maybe
could
it's
be.
all
Maybe
time.
he didn't say one way or the other. But
Yeah, I would assume maybe
Nevertheless,
that's all
it's
time.
an
Yeah.
outlier.
So we got close to all-time January record temperature, and you can see how anomalous that was just in the spread. If we scroll down just to the precip here, we're on the precipice of maybe entering a drought. As you can see, we haven't had any meaningful precip for months now, and it doesn't look like we'll get anything substantial in the near future. So this is something to watch. We're below normal for the first time since November. So that's something of note, and then we'll go to our sad snowfall map and look at that. I mean, very sad. 57 degrees is fun, but it's January, so you would want snow.
It's the end of January.
It's,
Yeah.
Let's go back up to the top. Let's see, the end of January, it should be below freezing for the entire day.
Yeah, but I'm talking about snowfall. Come on, it's over.
It is not over.
One other thing to say about January 30th, I don't know if you already said it, Patrick, I'm sorry.
No, go for it.
January 30th, 1951, we were minus 37, the
That's
coldest
okay.
ever in Madison. 57 yesterday is the warmest ever. It is now the day in the calendar year that has the greatest extreme between all-time high and all-time low, 94 degrees. And that's pretty awesome. And we lived through the warm side, so that was cool.
And there are people in Madison who live through both days.
That's true,
Sure.
yeah.
Which is kind of weird. Okay, so to that. Oh, can I go to my slimmest state map, please? And I'll show you this. So here's our record high, 57 degrees. If you showed me this map and told me it's from January 30th, I would think you're crazy.
Yeah.
Because there are 50s and 40s all the way through much of the United States, aside from the mountains. Temperatures in the 70s, 60s, all the way up. Places my sister lives in West Virginia, so I know this. Last week they had feet of snow, and now it's 50 degrees outside. This warm-up it's been gradual, but 57 degrees. And temperatures ranged, got into the 50s. Some places, Prairie du Chien and La Crosse got up above 60 degrees yesterday. And it's January 30th. You would expect the temperatures to be the lowest right around January.
Yeah.
Typically, but we just have no snow. And so you have no snow, you can heat up quickly once you get sun. Ground's dry, so it's gonna heat up faster because there's no moisture to remove essentially. So 57, 60 degrees across our state, which is crazy. And now it's gonna be in the 40s, which still feels anomalously warm, and it is anomalously warm, so crazy.
And we're running the fourth warmest Northern Hemisphere, December 1 through January 30th now.
Right.
And we're within range of any of the top 2, 3, or 4, or 2 or 3. We might not get number 1, we could be number 2 or 3.
Easily, and I know
Amazing.
I'm doing forecasting for Colorado, Steamboat Springs. Western portion of the United States is supposed to get record high temperatures going into next week, so I'm sure we'll make a run at least 2, 3
It's amazing.
for all-time record warmth.
That's just east of the Rockies for the record warmth expected?
West,
Oh, west.
so like right
Talking
behind the
what,
Front
west?
Range, yeah, all the way over here. It's gonna be in the 40s in Steamboat Springs, yeah, and they have feet of snow on the ground, so you can imagine that'll be messy. Could we go to our the current surface map, please? So that was from January 30th. We'll take a look at what's going on right now. Get our surface map here. So you can see we're in the 40s already. It's just afternoon and it's sunny. So a pretty nice day, especially for January. You can see the warmth stretches all the way up. Well, this is still pretty warm for this time of year. You can very much tell where there's snow on the ground and where there's not. Where it's in the 40s, no snow. Where it's below freezing and even in the single digits, snow cover. even snowing in places in North Dakota. But I want to point out, we have a surface low just to our south, and so you can see there's a nice band of rain that is not going to make its way into our region, but is producing pretty heavy rainfall just to our south, temperatures in the 30s in northern Illinois. And that's the only thing really to talk about. If you look here, there's general cloudiness associated with that disturbance over the eastern portion of the United States. Nothing else. Pretty nice day again, 50s and 40s out west. So again, if you show me this and it said this was January 31st, I would again probably think you're crazy, aside from the snowfall. It does not look like January at all. And it seems like it'll stay that way for at least a little bit here.
We'll probably see this on the radar, but
Yeah.
it's going to be tough to get that precipitation. We'll see the band of precipitation too far north with a, the dry air at the surface, dew
Absolutely.
point of 28, dew point of
Absolutely.
13. That's going to be tough.
Yeah, completely agree. It doesn't seem like we'll get any precipitation. Maybe along the state line might, but yeah, that's right. It's relatively dry. And as we keep heating up, it doesn't look like there's any moisture source. We have flow from the north. Dew points in the 20s, low 20s, so it's not necessarily going to get more moist over us, specifically here. Could we go to the super peaks, please?
Before, can we just
Oh,
go
yeah.
to that station north of
Sorry.
Little Rock? The only thing that was reported is a pressure fall. That's weird. You don't usually see that
Yeah.
as the only
Oh, good point.
observation.
That is
Pretty
weird.
weird.
Interesting. Sorry, can we go to the composite radar first? So you'll see here's that nice band of precipitation, pretty heavy reflectivities. If we could scroll down to the color bar. In the 50s and 60s, so that red color has shown up, especially over, right over Rockford. Looks like it's weakening at this time, but has probably produced pretty heavy rainfall for portions of Illinois. You can see it's already making its way to the southeast, so it's not going to impact us. Looks like maybe Racine is getting some rainfall potentially, but that's it. It should stay pretty nice over our region. We can see some of the snowfall over North Dakota, as was reported, and then there's lake effect going on over Lake Michigan. But this is the main driver of anything west or east of the Rockies. You can see the moisture flow is beginning to come in. A lot of precipitation ongoing. Looks like it'll continue for a while, so places, especially in California, are going to get hit with, I think there was some mountain forecast for over 100 inches of snow easily in 2 or 3 days, which it's a mountain, but that's still pretty incredible. And a lot of rain in the valleys and everywhere over here. So 2 systems, we're in the middle. We didn't get affected by this one, so we're going to be dry for the rest of the day, for better or for worse here. And so we can diagnose this rain band specifically because it seems, maybe it's tied to the system, but there seems to be a better forcing from the upper level charts of what's producing specifically this band and why it was so heavy as opposed to these bands, especially this thin line of showers that's been moving through portions of the southeast. So could we go to the super peaks, and I'll start at 925. So here's a look at the current 925 millibar chart. You can see we have our low geopotential heights, so tied to that disturbance moving over the eastern portion of the United States. You can see there's a really nice frontogenesis band. Temperature is 7 degrees Celsius over central Illinois. You can see there's a one contour of temperature, and then we have flow largely parallel to the temperature. So there's nice frontogenesis ongoing right where we saw that band of precipitation. One of the main reasons why it's not impacting our region is that band is largely situated over Illinois, especially at this time, which is early in the morning, and that matches up exactly where we saw the heavy precipitation. So this is 925. Could we go to 850, please?
So also, Patrick,
yeah.
before we switch that, so it seems as though that at this level, certainly there's a lot of confluence and undoubtedly frontogenesis going on, but
Yes.
maybe we'll see it further up where the temperature contrast might be a bit more.
Exactly right.
prominent.
Yep, exactly right. Yeah. Mostly it's the low-level confluence, and then there's not much of a temperature gradient, especially in the region where that precipitation is ongoing. Yeah, let's go to 850. So here we go. Now we have more of a temperature gradient in the vicinity of where we have that convergence of the flow. So this is, I believe, 10 Celsius. 7 Celsius, and this band here is 5 Celsius, so there's a decent temperature gradient. Still the same, we have southerly flow and then easterly flow, so this is really strong frontogenesis right over the same region. So we have forcing for this precipitation 925 and 850. Temperatures, the main baroclinicity, at least for now, looks to be a little above the surface. Could we go to 700 at the same time? And so we'll see again, it's not as obvious, but there is we have southerly flow and then the wind shift, along which we have a temperature gradient. And this seems to be the top of that main frontogenesis band. So it's all lower tropospheric, right above the surface, but there is a decent signal, at least a couple levels, where we have that precipitation matches up exactly where we saw it and where this is from 7 a.m. So as you can imagine, this thing shifts to the east. That's exactly where the precip is shifting as this whole thing, the system moves to the east.
So I'm curious how much, and this is where I guess like a Q vector diagnosis might be helpful. How much of that precipitation band that extends to the north and west of the cyclone might be more sort of convergent, helping to amplify the thermal ridge, so more QS convergence rather than frontogenetic?
We could take a look at the QG Omega page if you want. Yeah, good call.
I forgot about that.
We'll take a look at that here.
John, you're gonna have to.
I think it's if you go to the AOS Weather Watch links, it's at the
Okay,
bottom.
okay.
Yeah. Make your life easier. So we'll take a look at how much is that frontogenically force, how much is that along isotrope force. You can actually make that partition and hopefully it's this one.
Yeah.
And then, so let's first start with the total.
It's from 0 Z.
0 Z.
I'll do the forecast, I guess.
So 18 might be right around now.
Yeah, so there's the bullseye.
Okay.
South of the Michigan-Indiana border.
Yeah,
It's
okay.
moved to the east.
So, what's shown here is ascent is shown in yellow, the aqua is descent, so you can see right where that frontogenesis was, and this is a forecast for about right around now, maybe an hour later, you can see there's a bullseye of ascent right where we would expect it from that frontogenesis. What you can do is you can partition the Q vector and the associated ascent into flow perpendicular to the isotropes, so frontogenesis, or parallel to the isotropes, more shear-wise, rotation of the temperature gradient. So we can do that. We'll see, here's a bullseye, not particularly strong. It wasn't raining particularly strong, so that lines up, I would say. And let's take a look at that. Let's first start with the QN, so the transverse at 18. You can see it is small bullseye, not particularly, there's not a clear signal, I would say. So maybe it's not frontogenically forced in this model run a couple hours later. It was weakening, I could see from the radar. So small bullseye, let's check the along isotrope flow, shear-wise here. Little stronger, so interesting setup. Seems like they're about equal with the shear-wise, just rotating the temperature gradient seems to be the main driver, at least from this forecast here.
And, one should keep in mind that the frontogenesis represented in the QG system is weaker than the real. So if you were to look at the actual frontogenesis, it's stronger than that. And yet you get a pretty faithful depiction of this component from the QG system. So
True. Good
your
point,
statement
yeah.
about them being about equal is probably right.
Yeah, I would say so. So interesting. Looks like a clear signal of frontogenesis early on, around 7 a.m., but now maybe the whole evolution has weakened.
I think you're also right that if we go later into the forecast, I think the frontogenic component, particularly over New York State and New England, gets stronger over time.
Yeah, I could imagine that, yeah.
Confluence is really strong.
Yeah.
Yeah, I mean, you can see that on the maps.
Question, where did all this moisture come from that's being forced? Where did the moisture come from? It's dry everywhere else.
Good point. This whole band evolved in Nebraska and Kansas, so I wonder, could we go to the, let's go to 850 charts, and we'll go back in time and we can analyze that. And so we'll do the loop here. Okay, Tuesday. Let's see, can we go back to Tuesday? Let's see. if we can see a clear signal. So there is some flow off the Gulf, at least this point. It's over Texas. If we step forward at maybe 2 clicks, let's see how far north it is. Yeah, it seems like, so we have this ridge sitting over the southeast, flow generally from the Gulf. Low dew point depressions is the number underneath here, so 1 and 2 means pretty moist, I would say, especially for January. And it looks like maybe if we step 1 or 2 times forward, yeah. So that moisture, at least the southerly flow, makes its way up into Kansas. Dew point depression of 0 at this station at this time. And this was right when that rain band first began over Kansas and Nebraska.
There's a bunch of zeros in there.
Yeah, the whole
Oh, yeah, that's
southern
right.
plains is just about 0, yeah.
That's right. So
Basically moist.
very moist and
And warm.
Very warm for January. If we, let's go 2 clicks forward. Yeah, it seems like that those low dew point depressions follow along where we saw that rain band. So seems to me originated near the Gulf. We had persistent southerly flow for a couple days, and then this just continued. It's kind of isolated north of this system. It's just going to rain out. And if we step forward 1 more, yeah, we can see it's relatively moist too. Probably some more influence with flow out ahead of this system, I would think. But the initial rain band and initial rain moving from Kansas to Iowa seems like it was from the Gulf around Texas, I would say.
Well done. Oh, well done.
Oh yeah, thank you, sorry. And then let's go to 500, that'll be the last chart I show here. So this is a current look at the trough ridge, upper level flow. You can see here's the main divide between, we have winter in Canada and then spring-like temperatures. You can see the main wave train has moved north, relatively more north of the entire CONUS. So that would explain why it's warm over us, at least warmer. All the cold air is kind of trapped in Canada at this point. Here's our trough moving over the region. It's not too, it's relatively well stacked, it seems, where we saw the geopotential height minimums essentially over Illinois, just moving into Missouri. So not a particularly potent system. It's a nice trough, producing significant weather, but not going to lead to any significant development, it seems like. And that's reflected, I think surface pressures were just below average, like 10, 13 millibars or anything. So not particularly strong. And you can see what's on its horizon seems to be a ridge. So we'll get a little, maybe some clouds from this system that'll quickly move along, and then we're back into ridge conditions, drier.
Yeah, I'm noting how uniform minus 44 is as a temperature over central eastern Canada. Look at that. It's amazing.
Oh, yeah.
All these places are minus 44. That's about as cold as you ever get at 500 millibars.
Right.
And then there's the really nice cold advection and cyclonic shear around Winnipeg, Manitoba. I think that probably means that this whole trough grazes us to the north, and we
Yeah.
don't really get deep into that exceptionally cold air, which
That's
is
right.
widespread.
That's
There's
right.
a lot of it.
Yeah, I think the short-term forecast, I won't go into it too much, we get a little colder tomorrow, but then it warms back up right away. So that probably is associated with this little short wave that's just to our north, but you can see it. It's not particularly strong, not particularly long-lived, as the whole thing's just going to move quickly to the east.
And that westerly flow over the western part of the United States
Yeah.
and over the Rockies is, certainly gonna
Yep.
mean warmer weather for us
Yeah.
later in the weekend, at least briefly.
Yeah, absolutely.
Our colleagues in Europe have been running a dry run of their North Atlantic waveguide development experiment this week. And one of the things that they have been interested in is all the stuff over the North Atlantic, over the British Isles. There's been a lot of cold frontal passages and whatnot. But
Right.
boy, the pooling of the cold air over North America and the Labrador Sea has been noteworthy this week.
Yeah.
And
Yep.
we hope to be in the field in coordination with them next year, looking at tropopause polar vortices over North America, especially over Canada and the archipelago. If we could get a replay of this week, that would be just fantastic.
That would be nice, yeah. We have a record-setting storm in Canada. We had what we had last week with AON, which might have been affected by one of those things.
Yeah, which you gave a great diagnosis of that.
So that's the current weather, and I'll stop there. Is there anything anyone wants to see or questions? All right, I'll turn it over.
All right, thank you.
Before you say anything, can we just commemorate this moment? This is the first time we've had Michael giving a weather discussion in, well, how long? More than 2 years.
2.5 years. I did what is it, about a year ago for the anniversary, I was back out.
Oh, that's right, yeah. But in the real, operational every Friday, this is great. I'm so happy to have that.
So I'll start with apologies, this may be somewhat brief, and I won't be here next week, but I'll be here the weeks,
2 weeks
go
is
forward.
forward.
Just next week.
14.
Right.
That's 2 weeks.
Oh, that's 2 weeks, I don't even know what the calendar is. Okay, so let's go to pivotal, and then I want to go to the forecast as we have at the top. And then the first, the hazards. Okay, so, thanks Patrick for sort of giving us the picture of the current weather. This is a depiction of the National Weather Service current hazards across the United States. And even with that, the precipitation that we saw earlier, there is some flooding possibilities. Where's the scale on, or the legend, if we go scroll down just a little bit? Flood watch these areas. And I think part of this might be due to both melting snow, some of the current precipitation that's occurring. We saw that wasn't particularly heavy. But flood warnings in parts of West Virginia and southwestern Pennsylvania. And it's interesting that, West Virginia, up through the middle of last fall, was actually in a significant drought. And so now they're getting flood warnings in this area. It could be just because it's so dry and they're getting heavy precipitation on top of that. For the Western United States, as Patrick was indicating, in the central parts of Canada and northward, we're going to be seeing a series of weather events impacting the west coast, and that's going to lead to a lot of precipitation, likely in liquid form here is the flood watch, but then as you go into the mountains, into the Cascades and then into the Rocky Mountains, potential for some heavy snow, excuse me, with winter storm warnings in effect right there. So we'll look at some of the weather in the western part of the United States. The focus of my discussion today will be sort of from the central U.S. further to the east. So let's go first to the current surface map, not current surface map, but the GFS surface map for right now. And there we go. So over us, as Patrick indicated, there's that surface cyclone in northeastern Indiana, and the accumulated precipitation over the last 3 hours that's shown right here, with the heavy precipitation, the convective precipitation to the south, where stratiform precipitation across parts of the northern Illinois, Indiana into Ohio, and then maybe some mixed precipitation in some of the colder regions of the mountains over parts of Pennsylvania. And it's kind of clear that we have that we already saw from the surface maps that north to northeasterly wind over us with a cold advection occurring in the wake of this system. So yeah, it looks fairly likely that tomorrow is going to be a colder day than today, or a cooler day than today. And with the precipitation just toward the drier air being affected southward, that's going to kind of put a cap on how far north this precipitation is going to extend. Western United States, again with a broad southwesterly flow, lots of precipitation along the coast, rain, but then snow as you get again into the mountains of the western parts of the United States. Really cold over northeastern and central Canada. Let's step ahead to 12 hours of the forecast, so getting us to 0 Z this evening.
So 498 thickness is still higher than what we had last Tuesday over us. We were below 486.
Yikes. Okay, so
Unbelievable. If we'd had snow on the ground, it would have been minus 30.
I'm so glad we did. So that cyclone begins to weaken. Another minimum sea level pressure appears just around the Allentown, Pennsylvania area or so. Again, in its wake, with that cold advection continuing, the northern edge of this begins to turn into snow. Again, the convective line continues pressing to the southeast, approaching Savannah, Georgia, and southeastern Georgia later on this evening. But this band of snow we'll look at and sort of diagnose. This is where I think the frontogenesis is really beginning to pick up. So at this time, let's go to 850 hectopascal on this with winds and temperature. Yeah, let's just go to this upper air. First tab here. Please, 850. Okay. So by the time we get to later on this evening, that confluence at the surface is much more evident here. Now, obviously, the contour interval or the fill interval for the temperatures, the isotherms is a little bit different than we saw in the earlier maps, but it's pretty clear that there is a thermal gradient here. We do have frontogenesis, nice confluent frontogenesis occurring along this band. So at this point, it seems like a good fraction of the precipitation that we're seeing is being generated through frontogenesis over the eastern part of the United States. And again, with that cold advection on the northern side of this and temperatures dropping below zero at 850, this is all going to be likely frozen precipitation on the northern side of that. But over the southeastern United States, again, it still remains relatively warm. If we go upstream over us and further to the west, again, fairly strong cold advection over us. So this evening, we're going to see that the temperature's dropping later this afternoon as the cold advection begins to freshen up with a stronger northerly component to the wind. And if we step ahead to tomorrow morning, so 24 hours into the forecast, that cold advection is just about over at that point, and you can already see in parts of central Iowa into Minnesota warm advection occurring. So this is going to be a short-lived burst of cold air. As John was indicating, at 500 millibars, we saw that shortwave disturbance wasn't going to make much inroads into the northern part of the United States. It's already going to begin exiting. And so we're just at the end of our cold advection by tomorrow morning, and then things are going to begin to warm up at 850. It'll take some time for that to really respond at the surface until we get to late tomorrow evening into Sunday for a warmer day. But tomorrow's probably be cooler than it was today. I think very likely it's going to be colder than it was today. Over the western, or over parts of New England, strong cold advection. I don't see much evidence of the frontogenesis until you get out into the Gulf of Maine and points to the east and northeast, where we'll probably see a precipitation band. We'll look at the accumulated precipitation in just a moment. And with a cold advection all the way through the southeastern part of the United States, all that convective precipitation has now been swept offshore. Further to our west, nice vigorous cyclone, 850 hectopascals with warm advection ahead of it. Again, this is going to be something we're going to watch because it's going to be very interesting. Tomorrow evening, as this westerly flow begins to impinge upon us, we're also going to see a band of frontogenesis beginning to set up. And that could pose the possibility of snowfall somewhere across our state, but likely it's going to be to the north, as we'll see in the forecast. Let's look at the surface map first.
That used to be a routine ingredient for, a light 1 or 2 inch snowfall. Warm air advection from the lee side trough. It just hasn't happened this winter.
Yeah. So there's the convection, there's the precipitation there. And again, a little band of snowfall here. Again, this is with that western system that's moved into the Saskatchewan, or beginning to develop in Saskatchewan. And with a warm advection here, light precipitation. And one of the questions for this weekend is going to be how rapidly will this area, how much moisture is going to be associated with this, and how will they, if you will, forcing for vertical motion, how strong will it be as this nears us later in the weekend. So that's one of the forecast issues to look at. But for the West Coast, again, much needed rainfall continuing in sort of the Bay Area and points to the north. Other than that, it looks like it's going to be relatively a quiet weekend for us, for the country, at least weather-wise.
Weather-wise, yeah, I was going to say.
Let's go to 36 hours.
Thinking the same way.
Okay, so tomorrow evening. By the time we get to tomorrow evening, that thermal ridge has moved a little bit further to the east. Again, the warm advection is fairly prominent, and we already begin to see light snow breaking out over parts of the western part of or sort of the northern part of our state. And so, if we were to look, let's go just 3 hours ahead in this. We're going to see that the precipitation doesn't make it too far to the south. If we do let's look at a sounding. Let's create a sounding here just quick. Right about Madison. And you'll see that this layer of really dry air that we're going to have to overcome. It's really moist further, aloft. And if you imagine, if we can go back to the map for just a second, you can just close this out. Right, we have these layer mean isotherms, the thickness contours right here, indicating sort of a slope of the isotropes as you go further to the north. It's more moist above us, and so as that air is being dragged further to the north, it's going to be reaching saturation and creating the precipitation north of our latitude. So one of the questions is, again, just how far south, how much this lifting is going to have to occur before we reach saturation and actually get precipitation in our zone. But we have a layer of dry air that we're going to have to overcome.
And the lifting's probably really weak. That's almost a textbook region of uniform warm advection,
exactly.
which doesn't give you anything.
That's right. Yeah, you just look at the the sort of quadrilaterals formed by this are all about the same size, same contour interval. This is uniform warm advection, so it's gonna be really tough to get that. Okay, so let's go to 48 hours Sunday morning. Let's actually step forward every 3 hours, please. Okay, so closest approach maybe around midnight or so, we might see a few flakes of snow. We can actually just do another sounding roughly at the same location to see how much we've moistened up.
Oh, yeah.
Yeah, so we're actually getting,
Very nice.
right, and it's all gonna be frozen precipitation, at least by this measure, because the whole profile is below freezing.
God, I'm celebrating snowflakes.
Okay.
Sad.
What's that?
I'm celebrating individual snowflakes at this point.
So by the time we get, and then that, as the warm advection continues to move off to the east, and it's not just a uniform warm advection, but the warm advection moves off to the east, we're now, the precipitation moves off to the northeast, we're now in warm advection. So this looks like, clearly based on thicknesses, and we'll look at the 850 temperatures at this time. Actually, go to 48 hours, then we'll look at the 850 temperatures. We're gonna see that we've, certainly we're gonna warm up. So that area of precipitation gets a bit more intense as it moves into parts of Michigan. And temperature advection is kind of neutral at this point, and the threat of precipitation has now diminished. Let's look at 850 hectopascal, please. We should certainly see it's warmer at this point than it was on Saturday morning, when we had the shot of cold air tomorrow morning. So this is, at 850, we're just probably a neutral temperature advection, maybe slight warm advection occurring right here. You can see warm advection is a bit more concentrated here in parts of Michigan, southwestern Michigan into central Michigan, and that localized warm advection is gonna help force significant ascent occurring with sufficient moisture to get precip. So that's the snow that we're seeing over there. That thermal ridge hasn't quite made it over us. Let's go ahead at 850 till 54 hours. This is around noon tomorrow. Probably the warm, we're just about in the thermal ridge. If we do a sounding at this point, let's see how we, if we're gonna mix down at all.
40s.
Not really, it's not particularly deep mixing, but, I mean, the possibility, at least if you believe the model output explicitly, getting back to the middle to upper 40s isn't too bad for Sunday. And again, fairly dry over us, but maybe some clouds remaining aloft. Okay, thanks, Pete. And we'll go back to the surface map, and I'm going to begin to advance a little bit more rapidly in this map. So let's go to Monday morning, 72 hours. And by then, that cyclone's moved off to eastern Canada, and we have the cold air coming back in, and a band of precipitation beginning to set up just along and to our west at this point. If we step ahead in this, let's just watch this a little bit, because this is going to be a persistent band of precipitation. The models have slightly different solutions over the course of from now through Thursday, with the possibility at some point of a surge of moisture and warm advection that could lead to heavier precipitation. But the question is going to be, is it going to be frozen or freezing? Which the freezing stuff we don't really want, because that'll get icy roads and things of that sort. So here we are on Monday, mid-morning. Maybe some light snow over southern Wisconsin at this point. We can quickly go to 850 at this time, just to look at the thermal structure at 850.
Wow.
And you can see
Perfect.
nice, nice confluent frontogenesis along this band. So that's where we're getting the precip, or while there is some precip or some ascent occurring to cause that precipitation. If we do a sounding at this point,
That looks like a figure from an unimaginative, idealized model. Doesn't it?
yep, and we're fairly moist. So, we can't, I guess at this point I wouldn't say we rule out perhaps some light snowfall on Monday. So, John, I hope that's encouraging to you.
It's encouraging. In an environment of discouragement, I'll take.
All right, so
Best guess precip type here is freezing rain as a result of
free grazing drizzle. So so let's look at that. That seems kind of odd.
That's what you said. You
Given this is a zero isotherm, right? 0 degrees Celsius isotherm.
where would it be?
Where is the why freezing? Why
Why?
liquid? At this
I don't
best
know.
guess, whatever the algorithm is.
And why
suggesting.
drizzle? Just call it freezing. If it's going to be like this.
Right. So that's all right. So something to watch. let's actually, and we don't want to do a single deterministic forecast. Let's look at a couple of other solutions. I don't know if the ECWF is in just yet for this time period. Totally, it's already in.
That's the most
Here.
substantial frontage.
There is, these are almost 180 degrees
Yeah.
apart, but we have frontogenesis along this. If we do another sounding close to Madison, U.S. precipitation like none, and it's also much drier
I'm
here.
somewhat surprised, that's why, because
Yeah.
it's more strongly frontage I guess.
So, all right,
Drier, huh?
let's go out, and there's one more solution, Icon. This is the German model. The Deutsche Wetterdienst, and weaker frontogenesis perhaps, but if we look at this, this also looks a bit warmer, perhaps.
Yeah, oh, this is really interesting.
So,
You know that
if there's preset.
ECWF was the only one with a more discernible circulation in the lower troposphere. Maybe that
Yeah.
dragged warmer air that was previously subsided
Right.
into the mix, and these two don't. And that
That
might
could very well
account
be
for
it.
the difference in the dew point depression.
Yeah, so this is, so the forecast for Monday is, I would say, uncertain. Only 3 days out, and we're still kind of wondering, we may be wondering, will we get precip, and if so, what's the type, and then what's the intensity? Let's go back, we'll go back to GFS, to the GFS, and I'll just step ahead to, please, Pete, thanks so much for your driving today. Let's go to Tuesday morning, 96 hours. And decidedly much stronger cold advection. If we look at we'll just quickly go to the surface map, we're not going to see much occurring over us. If there's any precip, it's going to be along southern and central Indiana. It's just too dry. Cold advection is really taken over right here. Let's go to 120 hours. So we're getting to Wednesday. You can see so much the same thing. Precipitation is now beginning to break out. You can see some evidence of an inverted trough or trough structure, warm front beginning to develop well to our south. We're still dry. 144 hours, then we'll step through Thursday, but I think that's when it begins to get interesting. Again, all right, this is a different solution. Let's go to, if you don't mind, back up a bit, 132 hours. As this warm front begins to develop, there is the threat of some freezing precipitation just to our south. But again, the model solutions for this are kind of all over the place. A lot of uncertainty in the forecast. ECWF first, please, Pete.
Whoa.
So it has much stronger, much more vigorous warm advection, lifting this area of precipitation from well to our south to right over us and putting us in a band of mixed precipitation and rain with the snow further to the north. If you look at the icon, it's also a bit more vigorous, but it's further to the south. So we have virtually no precipitation from the GFS. Icon kind of putting us right in the middle of an ice storm, frankly, and then further, and then the ECWF ice and maybe just plain rain, liquid precipitation
Wow, that
over
is
us.
the most impressive ice storm forecast I've ever seen since I've been here. It's that dramatically obvious. Wow.
And I'm going to even take a quick look at the sounding from this particular forecast. We'll look at ECWFs as well.
Oh, man, look at that.
Again, that's a nice warm layer right here, and then really cold surface. Yeah, and that's a sleet, ice pellets being forecast. If we go to ECWF, we can just change the model.
Wow, same thing.
Yeah, even deeper, warmer layer close to the surface, but we're,
It is worse.
that's a lot of liquid precipitation. And here, freezing rain is the most likely.
That's the potential to be convective too, because if you can lift that slightly dry layer at the top of the inversion, that's gonna explode.
Yeah.
That's potentially unstable.
So that's that. And then if we get just, GFS to round this out.
Same thing, yeah.
Less freezing rain, drizzle, but maybe not as, again, any warm layer is gonna give us some melting in, so that's, so it looks like toward the end of the week, likelihood of some mixed frozen precipitation. If we just finally get to Friday,
Excuse me?
Yeah.
Just to clarify about ICON, is that non-hydrostatic, right?
I believe so.
Okay. Thank you.
Thanks for the question, appreciate it. And then, okay, there's Icon on Friday, oh, this is Saturday, let's go back to That's next Saturday. So a week from today, we're expecting to be back into the sort of cold advection, colder weather by the time we get to Friday, but we'll just look at the mix of the model solutions. So we'll be after we finish with GFS. Again, this looks much different, still cooler or colder, or cold, I should say, but a whole different complexion to the weather with warm advection already being set up again as this ridge, the anticyclones to our south. And for the GFS, at the same time, wow, cold advection. So location, this could be just slight differences in timing, but the end of the week looks like it's going to then begin to dry out, no matter what happens, middle of the week on Thursday.
And the Thursday ice, if it comes, will take a hit from the sun on Friday. That's good.
Right. So, again, for the weekend, looks like we're going to cool off tomorrow. Tomorrow will be a slightly cooler day than today, and the possibility of maybe some light snow tomorrow night. Sunday, decreasing clouds, temperatures warming up perhaps into the mid-40s, and then Monday through Thursday, clouds with maybe some light precipitation, some of it likely in the form of snow, or could be a little bit of freezing rain. When we get to Wednesday, Thursday, that's when the possibility of more significant precipitation that could be either frozen or freezing. But looks like on the balance, the model is suggesting freezing precipitation, so it could be rather icy toward the middle of next week. And then by Friday, we should be in much more decent weather. Anyway, thank you for your attention. Glad to be back, and have a wonderful weekend.